So here we will see the next miscellaneous problems. The standard heat of formation of NO2 and N2O4 are 8 and 2 kilocalorie per mole respectively. So what is the heat of dimerization of N2 in kilocalorie? So we have to write the thermochemical equations like N2 plus O2. So it is giving you NO2. So here you take heat of formation. So here for this we require delta H, that is 8 kilocalorie, and second is your heat of formation for N2O4. Okay, so N2O4, so again N2 plus O2, so this will give you N2O4. so N2 is 4 is there, so here you have to multiply by 2. So for this delta H is given here 2 kilocalorie. So but we have to write the equation 2NO2 is giving you N2 into O4. So this will be only possible, suppose this is equation 1, this is equation 2. So if you multiply equation 1 into 2, so if you multiply equation 1 into 2 and you will subtract by this is equation 2 minus 2. Okay, so we will get this equation 2N2 and 2O4. So in this case, so we will get, you have to multiply heat also. So heat will be your, this will be your plus side, so it will come here minus side. So here your minus 8 into 2, and this will be your plus, heat will be your 2 is given right here 2. So again delta H will be total 2, this is your minus, it will come this side. So this will be your, this is sorry minus, this is minus 2. So minus, it will be your sorry, this is plus now, this is plus, sorry, this is plus. So this is your minus 2, and this will, if you come this side, so it will be your minus 8 into 2, 16. So it will become minus 14 kilocalorie. Okay, so here is 2, so this is minus 2, so it becomes plus 2. So and this is plus, it will become minus. So this is our basically answer. Calculate the resonance energy of the carbon dioxide from the following data, that is delta HCO is given 339 kilojoule per mole, oxygen is given here 498 kilojoule per mole, and heat of combustion minus 393 kilojoule per mole. So this experimental data is given here. So again heat of combustion of carbon is equal to how much? So this is nothing but the, again we can write here delta heat of energy of the reactant. Reactant means carbon plus dioxide, that is here carbon plus oxygen, so we will get here CO2. Okay, this is our reactant, this is our product. Okay, so we will take the heat of this one, bond energy, dissociation energy minus this one, so reactant minus summation of heat of energy of the product. So this is carbon is given, carbon is converting into, in this case carbon is converting solid to gaseous state, and plus next is your delta heat of energy of the oxygen. Okay, this is the reactant, and minus and delta heat of the carbon dioxide. So this is given here carbon dioxide. So this is 2 into carbon dioxide. So we write here equation solid to heat, solid to gas is given here 718, plus oxygen they have given here 498. Okay, and this is 2 into product carbon monoxide is given here 339. So on solving we will get here the value is 678 kilojoule per mole. This is our basically answer. So what is resonance energy? So this resonance energy will be your delta heat of reaction, that is experimental, minus delta heat of energy, that is the calculated. So this is our calculated. So experimental is given here. So experimental is how much given here? So it is given here experimental minus 393. Okay, so right here 393, and this is experimental is given here 678. So this value is 678. So if you subtract this one 678 minus this is this will be double 670. This is 678. So it is written wrong. You can write here. This is 678. If you subtract this minus this, so we will get the value, that is 538. Okay, so here you subtract it, so minus 538, so we get value 931 kilojoule per mole. So this is our answer of resonance energy of the carbon dioxide in terms of bond energy. From the following thermochemical equations, ethene is hydrogenated to give you C2H6, that and the delta H is given minus 32.7 kilocalorie, and again benzene is hydrogenated to give you C6H2 and delta H is 49.2 kilocalorie. So calculate the resonance energy of the benzene. Okay, so already we have given here experimental data, so we have to go for the theoretical data. So two equations is there. So again we know that the resonance energy of benzene is equal to, again we can write here delta H of experimental minus delta H of again here we can write here calculated data, theoretical, that is called theoretical. So now here one thing we have to keep in mind, what, so here delta H is given 49.2. okay, so after hydrogenating, okay, so this is your exothermic energy, so write here the data 49.2 in positive value, and for calculated you can see here, so we require how much C2H6. so if you multiply this hydrogen into this much 3 times, okay, so what will happen, so we will get here energy, so it will be your 6 and this is 6, so it will be your here if you multiply by 3 whole, if you multiply by 3 this one, so we will get here C6, 6 is there, then again our ethene gas. So here if you give 3 moles if you are gauging, here we have to take 3 mole, so then it will hydrogenate this ethene gas. So our energy will be how much, so energy is already given here, so delta H is equal to 32.7. okay, so it will be 3 into 32.7. so this is the total calculated energy. Okay, so but we have to take in so positive form here, so here you take positive form because we have taken benzene energy in positive form, so write this 3 into 32.7. so on solving we will get here 48.9 kilocalorie. So this is our the resonance energy of the benzene, that is experiment minus calculated. Calculate the resonance energy in acetic acid from the following data. If the observed heat of formation, so here we have given heat of formation of acetic acid is 439.7. so already we have given the experimental data, we have to find the calculated data. So first we have to find the bond energy of the acetic acid in calculated form. So write the equations. Equation is, so delta heat of formation of acetic acid is how much, so from the equation it will come, so carbon, sulfur, carbon in solid state, and then hydrogen gaseous state, and then oxygen will be your gaseous state. So this will combine together, heat of formation, so we will get here HC, HH, and this is your CO, O and H. So there is 2 carbon, put here 2 carbon, there is a 4 hydrogen, put here 2 hydrogen. So this is your our reactant and product, so we will get some H value. So what is the H value, so for H value we will get here, so delta H will be for this carbon will be solid to gas, so this is 1433.4 for carbon, this one. For hydrogen is how much, so hydrogen is given here 870, HH is given here 218. So okay, here get 200, so we require H2 gas now, so it is 218, so it will be your 872. so how it will be, so again you multiply 4 into 218, so again oxygen is given here 249, so you have to multiply 2 into 249. so this is the heat of atomization given here for 1 atom, for 2 atoms, so here multiplied by 2. so here we will get carbon is 1 carbon, so we require 2 carbon, so this is your for 2 carbon, okay, for 4 hydrogen, here for 2 oxygen, and this is the reactant and minus product. So product is again here we can see CH is 3 times, so for CH 3 times will be your 3 total will be 1 2 3. Now I am writing product because there are 3 CH bond, and plus next is your CC bond is 348, so here CC bond is there 348, and plus here next is your C oxygen bond. The C oxygen bond is there. C oxygen bond is 732, that is the C oxygen bond. And again here next is your CO bond. The CO bond is here, CO bond, that is 351, that is your CO bond. And next is your OH bond. So OH bond is 463. So this is your OH bond. So now all is over. So if you add and subtract, so we will get here value, that is 3133 something, this value will getting here. Okay, so now just a minute. So not this value, this whole value is given here 2803.6, and this value is given here 3133. So on solving we will get here minus 329.4, that is kilojoule total value. Now resonance energy of acetic acid will be how much? Resonance energy of acetic acid will be your here heat of formation of experimental minus heat of formation of the calculated value. So this is the calculated value. Experimental value is given here already 439.7. So right here minus 439.7 and minus, this is given here minus 329.4. So on solving we will get here minus 110.3 kilojoule per mole. So this is basically our answer. So this is the way of solving reactant minus product. So on adding this value, so we will get this value, heat of this is the resonance energy of acetic acid in this question. The heat of calculate the heat of hydration of sodium sulfate from integral heat of solution of sodium sulfate and sodium sulfate 10H2O in infinite amount of water. So these two salts are dissolved in infinite water, so they will give you heat of hydration. For this sodium sulfate give it minus 2.34 kilojoule, and sodium sulfate hydrated this will be 78.87. So we have to find the heat of hydration of sodium sulfate. Okay, sodium sulfate we have to find out. So again first question is given sodium sulfate. Okay, it's mixing with the water, so this will give you sodium sulfate, okay, in aqueous state. So here delta H is minus 2.34 kilojoule. Okay, so exothermic reaction take place. So this is the equation 1. Second case, sodium sulfate, okay, 10 molecules of water. Again we are providing water. So in this case what happens, they will give you sodium sulfate aqueous solution, but delta H is how much? 78.87. so the endothermic reaction take place. This is endothermic. Okay, so again we have to multiply 1 minus, if you divide subtract equation 1, this is equation 1 minus equation 2, so we will get this equation sodium sulfate in solid plus 10 molecules of water will give us sodium sulfate in aqueous solution, and here again delta H will be your how much? So we are subtracting, so this is your minus 2.34, and this will be your minus is there, so again minus 78.87. so total value will be there minus 81.21 kilojoule per mole. So this is the heat of formation for the sodium sulfate in water. So this is basically reactions. 1 mole of anhydrous magnesium sulfate when dissolved in water evolve 92 kilojoules of energy. So here this is giving exothermic reactions, exothermic change. On the other hand, magnesium 1 mole of magnesium sulfate 7 molecules of water when dissolved in water absorb 14 kilojoule of energy. So when this hydrated salt is mixing in the water, energy is absorbed, but same anhydrous salt is dissolved in water, exothermic energy take place. So it is according to the equation we have to find the enthalpy change of this reaction. So as per the previous questions we have to write here. So right here first magnesium sulfate, so in solid they will react with the water, they will mix with the water. So here exothermic reaction take place, that is magnesium sulfate in aqueous state. Okay, so here delta H is how much? This is minus 92 kilojoule. This is equation 1. Second, when magnesium sulfate dot 7H2O is this solid is again combining with the water. So in this case we will get here magnesium sulfate in aqueous positions. Okay, this again equation, but here endothermic reaction, endothermic change take place. So what is the energy absorbed? Energy is 14 kilojoule. So again we can say here, subtract what? Subtract equation 1 minus equation 2. So if you are substituting this minus this, so we will get the above value, this value. So this value is what? Magnesium sulfate in solid plus 7H2O water. It will give you magnesium sulfate dot 7H2O water in solid. So not solid, it will be in aqueous state. It will be solid. Solid given, solid will be there. So here delta H will be how much? So delta H will be your, so this is here subtracting. So here minus 92 and this will be your 14. So if you subtract 14 also, so we'll get the value. The value will be your minus 106 kilojoule per mole. So this is the basically our answer.